All right, welcome to Economics 410, Applied Regression. In this video, I'm going to go over some f-tests in R. So I'm going to be opening up R to do that. The learning objectives for this is that you're going to be able to use R to get the test statistic. You can also get a critical value and a p-value for some different f-tests that you would use. So what are the different hypotheses that you might be testing? Well, it's going to be that either all of the coefficients are zero, so such as this example here, or maybe that some subset, and here in this example I'm just picking some things somewhat arbitrarily, coefficient 3 and 4 and 7 and 9, that these are zero. But any subset, it could be that 3 and 4 are equal to 0, or 3, 4, 5, just some subset. That's all that we're looking at there. So these are the two cases that we would have, potentially. And what are we going to look at in R to conduct these tests, or to get the appropriate F statistic? So for the first example where all coefficients are equal to 0, you're going to use the summary function on the model. And at this stage, you've already seen this if you've been following the course up to this point, which very hopefully you have, of course, and that's going to show the F statistic. So you've already seen that in that case. For the second case, you're going to use the ANOVA function, or you could use the linear hypothesis function that's available in the AER package. And I'll show examples of these in R in just a little bit. The critical value is also available using the QF, so that's quantile F function. There you would enter 1 minus alpha and then the numerator and denominator degrees of freedom. So df1 numerator, df2 denominator degrees of freedom. So the code for this is available in Canvas. You can download it and follow along. But I'm going to use the R code right now to show this. So here I am in R. I'm using the supervisor performance data that you've seen before. I've already run that, and I've already run this. I've got the full model here, so FM, run that. And then I run a restricted model or reduced model. Notice in this equation here that I've got, I've omitted x3 and x4. So those are, again, x3 is opportunity to learn new things, x4 is raises based on performance. So I don't have them in here. They're not in this RM model. So I'm going to run this model. It's going to be a bit different. Now, if I do the summary for the full model, so I have that in there, run that, I have the F statistic down here for the test that all coefficients are jointly 0. So it gives me the F statistic and it gives me the p-value, and I can find the critical value. Again, if I want the critical value, I would enter QF, so I'm just down here in this bottom segment. 1 minus alpha, so let's suppose that alpha is 0.05, so 0.95, and then the numerator degrees of freedom, I can find those up here in the output, 6, and denominator 23, so I'm just going to enter 6 and 23, 6 and 23, and then this will give me 2.527655. That is the critical value. So that's how I can do that. Now coming back up here, I have this ANOVA for the reduced model and for the full model, and then I can put in ANOVA for reduced and full model. Let me just give this first one here. So with this, now it provides me an F statistic down here and a p-value. So the F statistic is the 2.1088, and the corresponding p-value is the 0.1442. So easy enough, it's given those to me. But let me elaborate a little bit on how those are coming about. Where did these values come from and how that relates to some of the formulas that you've already seen, or the formula for the partial F statistic. Because again, this is comparing a model with only x1, x2, x5, and x6, as you see here, to the model that also includes x3 and x4, the full model. So I'm going to run ANOVA on the reduced model. So back up here in this console, run that, and I'm going to run it for the full model, and then I'm going to compare those two things. So notice in the reduced model, the sum of squares due to error is 1359.69 versus in the full model it was 1149, so 1149. So those are the different sums of squares for residuals, or SSE, and then we're going to use their respective degrees of freedom too. Those will play in as well when we get our partial F statistic. So what I'm looking at in this piece of code right here, it says using the individual ANOVA tables, is I'm pulling from those ANOVA tables, the ANOVA RM and the ANOVA FM. I'm pulling out their SSE values, sum of squared errors. Right, so I'm pulling it from, just asking it for that specific entry, those specific items, and I'm also getting their respective degrees of freedom. So that's what these lines are doing. It's pulling from those results. So I'm going to just run that. So that has grabbed out the elements that I need to find the F statistic. All right, so I'm going to give my F statistic, what I've got right here, is I'm pulling out the sums of squares from the reduced model minus the sum of squares from the full model. You may notice that if you go back to the lecture on finding the partial F statistic and how it's constructed, you'll see that that's there. And then that's divided by the difference in the degrees of freedom there, which is the number of omitted variables. So in this example, it's just going to be 2. And then I divide that by the sums of squares from the full model and divide it by the degrees of freedom for the full model. So I'm just going to run that. Hit that. Now down here, I'm going to actually ask to see what that value is, my F. And I have an expectation about what it's going to be because it should match what happened when I had the ANOVA with the RM and FM values. So you can see it's 2.108. And does that match what we had before? Well, let's go back up and look. And it matches this 2.108. That was the result of using this ANOVA and then putting in the reduced model and the full model in there. It gave us an F statistic of 2.108. So that's a match, and that's where that came from. Right? You can see that perhaps it's a little easier just to go ahead and use the ANOVA with the reduced model and full model term there, right? Instead of having to go through all this work. But I want you to see where this is coming from. I use alpha of 0.05, okay? And I want to find the critical value. So the critical F is just, I'm going to use that QF function, 1 minus alpha, and then the respective degrees of freedom. So I want it to show that to me. So critical F, and it's 3.422. And then I also want the p-value. We've already seen the p-value, but let's go ahead and just this out. And then let's go ahead and print it out. So p-value here, 0.14442. But we've seen that before as well. So if we go back up, you may notice that we had a p-value up here of 0.1442. So that's where that's coming from. So again, I think it's a shortcut to go ahead and just use this expression here as opposed to working through plugging in all the values, but certainly that is an option. Hopefully it helps you understand what's going on. I've already installed this package, already in this part here too. To help you get familiar with what this linear hypothesis function does, you can run this help function here. And then over in this panel over here, this pane, where it says help, this will show you. So again, where I'm looking is I'm looking over here. And it'll give you more details on what's going on with the linear hypothesis, so you can maybe use it in some different ways. And then I've got linear hypothesis. I'm going to use the full model that I had before. And I'm going to test the hypothesis that x3 is 0 and x4 is 0. At least the coefficients on those two things are 0. So I'm going to put that in there, run. And you'll notice it gives me results that I've already seen before. The F statistic of 2.108 and the p-value of 0.1442. So that's what I'm getting out of there. So you've got some options for how you work this. You can also choose to try something else. For example, let's suppose you want to try some other. Let's just play with this here for a second. Maybe you want to add something in here, like you want to check that the coefficient on x5 is also 0. So we can try this out. And you'll notice it gives a different F statistic, different p-value. It has run this for a different model, right? One where x5 is also assumed to be 0. And in this case, we would, again, here, fail to reject. We can tell it by the p-value if we're comparing that to an alpha of, let's say, 0.05. All right, so hopefully that was instructive and helpful. I recommend you go ahead and download the code. It's in Canvas, and then run it. Just replicate what I did, but then also practice checking some things for some other coefficients. Just play with some of the things. Maybe check that x5 and x6 have coefficients that are 0, or x3, 4, 5, and 6, right? Just play with it to help yourself get more familiar with what's going on and feel more comfortable with it.